All right, page 522 in your textbooks, and we are getting ready for a test coming up in lesson 170. This isn't going to be on it, but it's good review for our exam coming up shortly. We were asked to evaluate a series from 1 to 12 of 3i plus 2i squared. And what did we need to do with this rather complicated argument here? Maddie? And what do we separate it out to using a couple of different distributive properties? Michael?
3 series of I 1 to 12 plus 2 series 1 to 2 I squared.
All right, and so we're going to take a series of I, and what is my formula for a series of I, class?
N times n plus 1 all over 2.
Good, n times n plus 1 all over 2. Of course, we also have this 3 that needs to be multiplied. And then what's the formula for the series of I squared, Brandon?
N times n plus 1 times 2n plus 1 over 6.
Good, so n times n plus 1 times 2n, 24 plus 1, 25, all over 6. Of course, we also have to multiply the 2. We do a little bit of canceling here, do a little bit of canceling here. We multiply, we add those two things together. What do we get for that series, Audrey?
1,534.
Good, 1,534. The other option, of course, is you plug in a 1, you get that number, you plug in a 2, you get that number, you plug in a 3, you get that. You do that all the way up to 12 and then add them all together. You would get the same thing. A lot quicker to do it this way. How many have that answer? All right, questions. Number 4, how will we split that one up? This one's a little weird looking on the surface, but not actually that bad. Abby?
I was gonna go straight. Okay. 3, no. My brain's not working. 16 times 17 times.
Well, I'm just saying, how do we split it up? How do we take what they gave us on number 4 and split it up?
You do the series of 1 to 16 with the I squared, and then
What goes in front of it?
the 1 over 3.
The 1/3. Good. The coefficient of the I squared is a 1/3. So we need a 1/3 out front. Good. Then?
And then negative 4 times the series of 1 to 16.
Series of I from 1 to 16, all right? So we're going to take the I squared, which again is the n plus 1, 2n plus 1, all over 6. And this is what you started to say a minute ago, I think. And then we also have a 1/3 being multiplied here. So we can cancel the 6 a little bit here, class, to get 3 and 8. I could cancel the 3 with the 33 to get an 11 and 1. And I told you you're always going to be able to cancel, but it doesn't cancel with the 1/3. So we end up getting a fractional value here, minus 4 times, and then we've got the same n plus 1 over 2. That cancellation's a little bit easier. So we're going to take a fraction value, or mixed number, minus a value. What do we get for that final answer? And it does come out negative. What was your final answer there, Abby?
Negative 45 and 1/3.
Negative 45 and 1/3, or negative 45.3, repeating if you left it as a decimal. Goodness, what would that be? Negative 136 thirds if you did an improper fraction. How many had one of those answers for number 4? All right, questions on that one. Number 5, we have a geometric sequence, meaning we're going to multiply by, what do we call that thing? We multiply by the common ratio. Remember, arithmetic is common difference, common ratio. What's the common ratio in number 5? Audrey? All right, we're multiplying by 5 each time. So the next term, we're going to multiply by 5 again, and we'll end up getting
1,250.
1,250. How many have that for number 5? Number 6, what's the common ratio here? Maddie? Yeah, whatever a number is divided by the previous term in the sequence. And you found the common ratio to be...
This is 31, 38 point in a decimal.
Well, it should be 3/4. So you see we're multiplying the numerator, because if you think of the first as 115 over 1, and then it's a 345 over 4, and then it's a 1,035 over 16. But even calculator aside, you see the denominator is increasing 4, a multiple of 4. Numerator is increasing multiple of 3. So the common ratio is actually just 3/4. We take their final number that they gave us, multiply that by 3/4 again, and what fraction do we wind up with now? Good, 9,315 over 256, or you might have had 36 and 99, 256. How many had that answer, or one of those answers for number 6? Questions on any of the 3 through 6? And this is not on the test coming up, but good review as we think about an exam. All right, turn over now to page 532. 532. And again, the first few of these were not going to be on the exam here, but they wanted to find the sum of the indicated number of terms in a sequence. Class, what term refers to the sum of the values in a sequence? A series. So we're finding a geometric series. Now remember, in arithmetic series, we use the summation notation, the Greek sigma. Geometric series, because we don't have upper and lower bounds, we don't need the sigma notation. We just use an S, and we're going to find the sum or the series of the first n terms. Hopefully you went back and found the formula from your formula page. What's the formula for a geometric series? Does somebody have it written down? Abby?
A1 times 1 minus RTN over 1 minus R.
Perfect. Hopefully you went back and found that from your formula page, and then just plug in the values. It says it wants the first 7 terms, so that's S sub 7, of the series defined by this, of the sequence rather, defined by the algorithm 10, which is my first term, times 1 minus, apparently the common ratio is a 3. We're going to raise that to this 7th power, all over 1 minus 3, which of course is going to be a negative 2. What do we get for our answer on number 1, Michael?
10,930.
Great job, 10,930. How many had that? Questions from those who didn't. Did we use the correct formula? We did not. Did you try to plug it in and actually find the individual terms and then add them, or? Okay, easier way here, but you have to look up the formula. So take a moment, since many of us didn't have it, do number 2. Take just a moment to redo number 2. The first 4 terms of the sequence defined by the algorithm a sub n equals 4 times 9 to the n minus 1. Unless, of course, you're confident you did correctly already, in which case you can sit there and wait with a smug look on your face. Always a smug look on the face. Very important. All right, class, we're going to write S sub 4 is equal to, what's the first term? 4 times 1 minus, what's the common ratio? 9. And we're going to raise that 9 to the 4th power, all over 1 minus the 9 again. Remember, start with the 9 to the 4th, subtract that from the 1 to get a massive negative value. Multiply by 4, divide it all by negative 8. What do we get when we rework the problem, Brandon?
3,280.
3,280. How many had that for number 2 when you reworked it? Still not? Okay. Start with the 9 to the 4th. And I would take the, make it a negative and add 1. Or you could just remember the number, do 1 minus that. Multiply that by the 4, which is the common ratio. And divide it all by, you can see from the denominator it's going to be a negative 8, so divide it all by negative 8. There we go, we have it now. And of course yours is pretty straightforward, just manual, straight up entry. Got it now? All right, good. Number 3, define the sum of each infinite geometric series, where instead of an S sub n, there is no sub n. It's all of them. It's the entire series. What's the equation for an infinite series, infinite geometric series? Who looked that up? All right, Brandon?
S sub n equals a sub 1 over 1 minus 1.
There we go. So we're going infinitely here. And so we just take the first term, class, 9, and we divide by 1 minus. Now, what is the common ratio in number 3? Kendall? What do we keep multiplying by?
1/9.
1/9. So we do 1 minus a 9th, which of course is going to give us 8/9. We divide the 9 by the 8/9, and we end up getting what? Anyone? 10 and 1/8. There we go. Sorry, I was waiting for an 81/8, but that is 10 and 1/8, or 10.125. How many had that for number 3? All right. And by the way, this only works because the series or the sequence is getting smaller and smaller and smaller. It's approaching 0. What do we call a sequence that approaches 0? Convergent. Is the next one approaching 0? Yes, 11 is getting smaller to 5 is getting smaller to like 2 and 4, 11. So it keeps getting smaller and smaller. So we can also find this, except this time the a sub 1 class is 11. What's the common ratio here on number 4? 5 11ths. So we're going to do 1 minus the 5 11ths, which is 6 11ths, of course. We end up getting what for the infinite sum? Anyone? 20 and a sixth, or 1 and 21 sixths? Something like that? Questions? All right. Number 5. Now we're to stuff we're going to see on the test. All right. Permutations. It says using the formula. Hopefully you didn't use the formula. But what is the formula of n items taken r at a time? Well, remember, class, for a permutation, the order does matter. Okay, so the order makes a difference here. What's the formula for a permutation, volunteer? Michael?
Use formulas.
Way to go.
N factorial over the quantity of n minus r factorial.
There we go. And but we also had a button on the calculator that could do it. But either way works, right? And remember that factorial, that little exclamation mark thingy there. What is a permutation of 20 items taken 5 at a time, Michael?
1,860,480.
Great job. 1,860,480. What about for number 6? Permutation of 14 items taken 2 at a time. Audrey? 182. Then for number 7 and 8, we're finding combinations. Again, a combination, class, of n items taken r at a time is where the order does not matter. There's not any specific this before that really makes a difference. Formula is very similar. What is it, Abby?
The formula is
As I think deeply while turning in my notes.
n factorial over r factorial times n minus r factorial.
There we go. Hey, nothing wrong with needing to look back at the notes. We hadn't done it in a while. You don't have to use it because we've got the button on the calculator. You do have to know the formulas, though, for the testing purposes as we think ahead toward that. What is a combination of 20 items taken 8 at a time, Brandon?
Number 7? 125,970.
Good, 125,970. What about a combination of 11 items taken 9 at a time, Maddie? 55. Questions on that? All right, now to more recent stuff that we've been working on a lot more recently. It says find the complement of each event. What is complement again, Kendall?
It's like the opposite, or like what's not going to happen.
Right, the probability that something doesn't happen. So it says for number 9, Brady ate an apple 300 days out of the past year. How many heard that apple a day keeps the doctor away? Is that actually true?
You just have to have.
We think it's false. We're not positive. His mom apparently subscribes to this philosophy, though. 300 out of the past 365 days, he eats an apple. It says, what is the probability that he will eat an apple? But in the directions, it doesn't want the probability he eats an apple. It wants the complement. So we're actually finding the probability he doesn't eat the apple. As a ratio, unreduced, what would that be, class?
300 over 360.
Well, that's the probability he does. It said it wanted the complement, meaning the probability he doesn't. 65 to 365, and we could reduce it if we wanted to. I'm actually interested, what's the percent chance?
17.8.
All right, we find out finding it's about 17.8% chance that he doesn't have an apple on a particular day. How many got that answer? How many got the actual answer of eating the apple and didn't notice the direction, specifically wanted that comp? Isn't that annoying? You're like, why don't they just say what's the probability he doesn't eat an apple? Because they're annoying like that, all right? Number 10, Jordan washed the dishes for his mom 26 out of the past 40 days. By the way, Mother's Day coming up, right? Thinking of things to do or to give to mother to show your appreciation. What's the probability he washes the dishes? Well, it's not 26 to 40. It says it wanted the complement, so class 14 to 40. What would that be as a percent chance? Find it quickly.
35.
And we do get class? 35%. 14 to 40 is 35%. If we left it as a ratio, we'd leave 7 to 20. But if we wanted the percent, 35%. Questions on that? Number 11 says relative frequency. What is relative frequency, Audrey? It's a form of probability, but it's a little different. What makes relative frequency different? Michael?
It's based off of past events.
It's based off of past history. So we say, okay, all odds are equally likely. Based on what's happened in the past, these are the actual odds. So Natasha has won 12 of the past 35 swimming competitions. What's the probability she wins a swimming competition? Your answer was 12 to 35. What would that be as a percent? At your seats, find it. 12 to 35, the answer, if we wanted a percent, though, we would say it is
34.3.
Now, again, if we don't have past history, it's 50%. Either she wins or she loses, right? But based on past history, 34.3% chance that she wins. Victoria has missed 3 of the past 35 school days. Shame on Victoria. If she's watching, what is the probability that she will miss a school day? And what do we get as a percent that she'll miss school on a random day? Brandon?
8.6%.
8.6%. 3 to 35 or 8.6%. How many had those? All right, questions? Questions? Yes, ma'am.
Do we need to have it as a ratio, or can we just have a percent?
Either one's fine. Yeah, I'm just kind of giving both answers so that way we're good with either. Yep. Okay, good question. Unless, of course, on a quiz or test, directions would tell you either ratio or percent. If it doesn't specify on quiz or test, do whichever you want. Okay, because that means I'm leaving it up to you. Good. Any questions? Flip back to page 524 then. Page 524. I want you to do numbers 10 and 12. 10 and 12. And since these fractions get pretty gnarly, let's go ahead and do percents. I think that'll be easier than some of the weird fractions we're getting ready to face. So let's go ahead and do the percents, just because I think it'll make the numbers easier to look at. Big ugly fractions can be frustrating. It's not bad when you're talking about, okay, there's a 17 out of 58 chance, but it's like there's a 373 out of 10,984 chance. Yeah, give me a percent. Ten and 12 on page 524. Michael's got them. Abby's got them. Brandon's got them. All right, for sake of time, let's take a look at these. Even if you're not finished, just going over them I think will help. Veronica has 60 different colored marbles in a bag. Of course she does, it's a probability chapter. 19 blue, 15 yellow, 12 red, 14 green. I know, no creativity in these problems. There's only so many you can do in their defense, I mean, you know. Anyway, probability of a blue or a green marble. Well, there's 19 blue and there's 14 green, so that's 33 out of 60 or class. 55% probability. Red or yellow, class? 45%. 27 to 60 reducing down, and then 4 to 5. What about blue, yellow, or green? 80%. Pretty much anything but red, right? The complement of red being taken there. Are we good to go on number 10? Should be straightforward. Number 12, this one didn't give you a total number of flights. Like, so the first one, they gave you the total. Here you had to find the total. How many total flights were there, class? 15. So the probability of picking a flight to Cairo or a flight outside the United States. Well, what should you immediately think when you hear that? Cairo is outside the United States. So don't even worry about Cairo. Just find the probability of flights outside the U.S., which, let's see, that would be Cairo, London, and that's it. So how many flights is that? 7 to 15, which gives us 46.7%. Flight to LA or to California. Well, again, LA is in California. So really it's just LA and San Francisco, which is, yeah, 7 flights again. So again, 46.7%. How many had that? And the last one, flight to Seattle or flight inside the United States. Man, they're annoying. Again, Seattle's inside the U.S. So basically, by the way, inside the U.S. would be the complement of letter A, which was outside the U.S. So I could just subtract from 1 to get 53.3%, or I could actually take the time to do the math, but I'd rather just subtract from 1. Questions on number 12. All right, do 14 and 15 at the bottom of the page. 14 and 15 at the bottom of the page. Yeah, still do percents, especially with these. These ones are actually where the fractions get worse. The last ones, I was a little ahead of myself. The last one, the fractions weren't that bad. These ones, the fractions are awful. Anytime you multiply with that and. So all that talk of rain and pouring rain and tornadoes this afternoon, we got a torrential downpour at 8 o'clock. Nothing since 8:30. Doesn't look like we're going to get any more rain the rest of the day. Just enough to knock out field day today. But it means we get to go outside and play volleyball. PE, that's happy. Brandon, you want to go play volleyball? You can come watch.
I could watch the one, but the one that likes to argue about if she's not.
You want him to come the line judge?
Yeah.
Oh wait, he might be have favoritism or bias because he likes one of the captains.
I won't be
We can't do.
biased.
You're joking. You're like, I will be biased. Okay. Gavin, fond memories of PE, the good old days. Was that a question, Abby?
How do we turn 14C into a percent? Because it's too big to enter into a thing and I don't.
You don't enter it as a fraction, enter it as a division problem. So take the top divided by the bottom, rather than doing fraction and then the fraction to decimal. That's actually slightly, I think, 1 or 2 keystrokes faster anyway. So
15, okay.
14 and 15.
Did we already do 15?
I don't think, we did a fork, knife, and spoon problem, but it wasn't this one. Oh yeah, it was page 522, number 7, had forks, knives, and spoons. It's a lot of forks, knives, and spoons, though.
Why do we need to know the probability? You already know what you're going to grab.
Really, it's just a means of making sure you know how to think them through, I guess. Yeah, at least they did shells instead of marbles for a change, you know?
Mm-hmm.
Give them credit for something. All right, for sake of time, I'll put you out of your misery here. And so they couldn't have done it 2 minutes ago. Blue shell, red shell, chosen in that order with replacement. Well, first you have to find the total number of shells, class. Number 14? 27 total shells. Find that. We do the blue, which is 10 to 27. We do the red, which is 8 to 27. I would do a little reducing, but you end up converting it to a percent anyway, so you didn't have to, I don't suppose. Kendall?
11%.
Right at 11% probability. Again, with replacement, we didn't need to change denominators or anything. They're independent of each other. What about green and then blue without with replacement? Michael?
12.3%.
Slightly better odds, 12.3%. What about blue, then red, then green? In that order with replacement. Maddie? 3.7%. How many had those for number 14? Now, number 15 is where we had to adjust, because it keeps saying without replacement, class, which means that these events are dependent selections. So the fork is going to be 31 to 104, but then the knife is 40 to 103. We end up getting, Abby?
11.6%.
11.6%. What about knife and spoon with no replacement, Audrey? 12.3%, same as green shell, blue shell. Anyway, then what about fork, knife, spoon? These numbers are like the same. What do we get for that?
3.6%.
I got it rounding to 3.7. Yeah, they're saying as well. So rounding error, 3.7%. Questions on that? Turn over to page 547 then. Page 547. Do numbers 5 through 10. Numbers 5 through 10. Some of these will be a little bit more interesting than what we've been doing. 5 through 10 on page 547. And as always, of course, if you're watching on YouTube and you're not quite sure about some of these things, make sure you reach out. feels like the students in here are getting it pretty well. That doesn't mean necessarily that you are if you're watching. So email me if you have questions. Abby's finished. Brandon's finished. Michael's finished. I saw Abby down. I look over at Michael's like, he's not done yet?
That was just because I didn't go to this page when I was bored in study hall.
Ah.
Yeah.
I know.
This is between you and Brandon. You can see yourself out. This is an MNP conversation. You can see yourself out.
She got it.
But A and B, that's how the thing goes.
It's your, but not A, it's M, because you're A, and you're not
I
in.
know, but the joke is A and B.
Yes, yeah, but you got it.
Oh, I knew it. I was just saying the letters didn't work.
I'm trying to figure out how he's doing that.
What flavor the nachos? It has nothing to do with how you breathe. It's just you control the muscle.
All right, let's take a look at numbers 5 through 10. Connor has hit 180 hits this season. He has 102 singles, 34 doubles, 2 triples, 42 home runs. What's the probability he'll hit a single as his next hit? And what did you get for this, Brandon?
56.7%.
56.7%, 102 to 180, or maybe you reduced and went 17 out of whatever that is, 30, 17 to 30? Is that right? If you do a reduced ratio?
Did he hit that well for softball?
I don't remember. Number 6, Robert has won 38 of the past 43 tennis competitions.
Get it.
I wasn't actually that good. I was decent at tennis, but not great. I did enjoy tennis, I should say. I haven't played tennis in a lot of years now. What's the probability he'll win his next tennis competition? Audrey? 88.4%, 38 to 43. He's pretty much a lock to win. Bet your money on him. Just kidding. We don't advocate gambling. Number 7, Kimberly has a collection of stickers from all of her perfect math quizzes. She has 15 blue, 32 green, and 10 yellow, which means they can't be from me because I tend to give the girls pink stickers to use them up. What's the probability Kimberly will randomly... It's rough to be a girl who hates pink, though usually if I know that I try not to give her pink. But anyway. No, I don't do that? Okay. And what's the probability that Kimberly will randomly select a blue or yellow sticker from one of her perfect quizzes? Well, first you had to figure out how many how many stickers, class?
57.
57, and so blue or yellow, 25 to 57 comes to Abby.
43.9%.
43.9%. How many had that for number 7? Number 8, Robin has different colored skirts at home. 4. I can't imagine a girl with 4 orange skirts. I can imagine 1 orange skirt. 4 orange skirts? You have 2 orange skirts. Okay. Like, I can see lots of different blue. I get that. My wife has a bazillion blue things because she looks good in blue. 6 pink. There's a varying shades of pink. 1 black. 9 brown. I feel like a guy wrote this problem and had no clue what he was doing. He wasn't a married man. What is the probability Robin will randomly wear a brown skirt? Abby? I point right at Maddie and say, Abby. Maddie. 45% chance. There we go. Out of 20. 9 to 20. Jack plays on his high school basketball team. There are 2 freshmen, 5 sophomores, 3 juniors, 4 seniors. What's the probability that the next guy who goes into a game is a sophomore? See, we only have a couple sophomores in here. Let's go to the only guy sophomore we have in here. Brendan.
Sweet. Okay. 35.7%.
35.7% chance you get in the game. Or Jack does. Trevor ordered a box of donuts. There are 2 strawberry glazed, 4 chocolate glazed, 3 raspberry filled, 3 apple filled. No boring ones. Even boring is good. What's the probability Trevor grabs a chocolate or a glazed donut? Kendall.
26.7%.
How many possible?
4.
Out of, 4 chocolate. How many glazed?
None.
There are. 4 of them are chocolate glazed, and 2 of them are strawberry glazed. So how many glazed donuts? 6 glazed, but chocolate already is glazed, so they're not mutually exclusive. So we really just need the glazed because that includes the chocolate already. Should go 6 out of 12 to get 1 to 2 or 50%. How many saw that? I know the wording was a little bit weird, so I get where you were coming from there. Questions on that? Questions at all on probability? We've been working on this for like a week now. Feel like we got it? All the different randomness they throw at you? We're good? We're ready to shine? Like, give me this quiz already. Like, get this 100 and end the week on a high note.
No.
Yes, clear us except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away.
No calculator?
Okay, you can have a calculator. Sorry. I taught lower level maths this morning, and so there weren't calculators. So I just got used to a sheet of paper and pencil. And I taught an English class, and I was also sheet of paper and pencil. So sheet of paper, pencil, calculator, everything else away. I need sleep. Sheet of paper, pencil, calculator, everything else away. First last name. At the top of your paper along today's date, which is 5/6/22. 5/6/22. Today's date. Revenge of the 6th. They usually do that on Revenge of the 5th, right after Star Wars Day. Anyway, Revenge of the 6th. Let's stretch it out one more day. First last name, 5/6/22. Today's date. This is quiz 36. Let's take a look at it together, and then we'll let you get started. 1 through 6. Write the word or the phrase that best completes each statement. Number 2, we'll need 2 words to complete the phrase. Number 6, there are 2 blanks, so I'll need 2 different answers for number 6 in the particular order requested. For number 7 through 12, determine the likelihood of each of the following situations. Notice it says round all answers to the nearest 1/10 of a percent. So we've been doing a lot more percents lately. We're going to continue that trend on the quiz. And there's a bonus for you as well. And so I try to describe playing cards if you're not familiar with them. If you're not, do your best. If you are, you know exactly what I'm talking about. And yes, you'd have a little bit of an easier time with that bonus. I'm going to end the video here. I'll put the homework on the board, and we'll end there. Should use that quiz copy as a cover sheet.